Why are you taking a picture of me? What the hell?
Snapchatting.
Oh, my pants. Dude, this is not even started yet.
Oh, you're a Facebook guy.
Congratulations. This is so hard. This is like I'm recording him. Look how still my hands are though. I'm pretty impressed.
We have 9 problems plus 1 bonus. 9 problems, which will make 18 points. 18 points, which means each problem is worth 2 points. So 1 extra, so you can get extra credit. There will be number 10. When you do all 10, then you get 2 extra points, which is good. So you need to have tantrum, the fixed tantrums. I will give you the exam. You can use that hard copy to solve the problem. Enter the answer, bubble your tantrum. You keep your exam and turn this tantrum back to me. I only need your tantrum. Okay, that's for Friday. Today I will give you some idea about what kind of problems you are going to solve. This will be chapters 1, 2, and 3. Three chapters, all about kinematics. The formulas will be given. Your first page of your test will be just for equations. And then you will see the problems for next pages. So basically, all you need is this equations of kinematics, and also in two-dimensional motion. If there is something is thrown into the air at a certain angle, you can convert the velocity into x component of velocity and y component of velocity, certainly. So these are the basic equations, and I will do the problem by problem, and I'll show you how you select the equation and how you do it. So these are the level of difficulty is the same as your quizzes and your homework. So same kind of problems, and you have a good idea what kind of problems. So this is one of those problems, as you can see. It's kind of familiar. So I have you have a sense that you have seen this before. So there's nothing, no tricks, no new unexpected kinds of problem. But always keep a certain initial velocity at certain angle. Typical case of a projectile motion. So you need to determine how high this object will go, which is maximum height and goes down. What is this maximum height? Okay, and then what is the velocity, total velocity of this ball at a certain time point? In this case, 0.9 seconds from the start. So maximum height. So for maximum height, height is distance, right? Vertical distance. When you look at these formulas, so you are given initial velocity and time, you are talking about distance, vertical distance. So I'm looking at this, can I use this? Okay, but you always, for projectile motion, you always know one thing. Well, that is acceleration in y direction, acceleration perpendicular direction, vertical is negative g, g downward. And there's no acceleration along x-axis. ax equals 0, ay equals negative 9.8. That's something that you know. Okay. Now I'm looking at this. I'm trying to find distance. There's no distance. There's time. So this doesn't look good. This is the distance. I can use y, but there's time. So I have no idea what I'm here. There's velocity. I know initial velocity. There is acceleration along y-axis. It is g. Distance, vertical distance, velocity. This looks a good choice. Okay, I tried to use this formula to find maximum height. And also, you know one more thing about projectile motion. So vertical velocity becomes 0 at the top. Okay, at the top, if this is projectile motion, at this point, dy becomes 0. dy is positive 0 and then becomes negative. Because it goes up, positive 0, and the top negative becomes down. Okay, now I can write this equation, this number 3. For y component of motion, I can write it this way. This is a final, I'm considering the motion from start to the highest point. Okay? And then my final velocity, I mean the velocity at the highest point. V final squared equals V, I'm writing this for y component of velocity, is V 0 y squared. I'm trying plus 2 times acceleration times distance traveled. First of all, I'm considering a vertical component. Y component, A equals negative g, and this would be basically the height. I can write minus 2gh. Okay, h is vertical distance traveled, and from here, I know one thing, that y component of velocity becomes 0 at the highest point. At the highest point, this becomes, once this is maximum height, this becomes 0. So this equals 0 at maximum height, right? So this whole thing becomes 0. And then I am given total initial velocity. Here I have y component of velocity. Then I know that y component of velocity is v0 sine theta. I replace this v0y with v0 sine theta, and this equation becomes v0 squared and then I can solve it for maximum height. Okay, I know V0, theta is given, G is 9.8. I just plug in the numbers and find the maximum height. Part this says find velocity at 0.9 seconds. Again, I'm just using the arsenal of my weapons that I'm using to have this problems. Velocity at a certain time. Okay, this looks good. Number one, I know initial velocity. There's one acceleration of the y-axis g. If time is given, I can find velocity. Okay, total velocity. I'm looking for total velocity at 0.9 meters. However, this thing is going at a certain angle. So at any point, any time point, it will take x component of velocity and y component. So I try to find vx, and vy at 0.9 meters, and I'm using this formula. V equals v0, this would be v0x for x component plus acceleration in y x component times time. And vy would be v0y plus acceleration in y direction and times time. So I'm writing this formula for x and y directions, and then start thinking what can I do? I know that for a projectile there is no acceleration along x-axis, so this goes away, then v0x is v0 cosine theta. So this equals v0 cosine theta. Okay. It is constant, it doesn't depend on time, by the way. X component of the velocity is constant. There is only change velocity along the y-axis, because there is no acceleration along x-axis. And this would be v0 sine theta, right? v0y, v0 sine theta. Acceleration along y-axis, negative gt. I know t, I know g, I know v0, I know the angle. So I calculate the velocities along x and y-axis. For x component, I get 12.3 meters per second. Just multiply this v0 with the cosine of the angle. And for y velocity, v0 sine theta minus 9.8 times 0.9 seconds, I get 9.4 meters per second. It's still positive. Y component velocity can be positive, becomes 0, and then goes down. And then total velocity that I used 0.9 seconds for time. I'm trying to find total velocity at 0.9 seconds. I use 0.9 here. Total velocity is vx squared plus vy squared. I know both of them, so I get 15.5 meters per second. Total velocity at 0.9 seconds from the start point. Okay, let's move forward because we don't have much time. So this is the other problem. So you are throwing a piece of rock at the top of a cliff, and there's the other cliff in front of you. So this is the trajectory of this throw. So it's initial velocity is horizontal. It goes horizontal, and then it hits the cliff in front of you. But it travels a certain vertical distance, delta y, change of y coordinate. You should find a relationship between this delta y, how much it falls vertically when it travels distance d. You need to find a relationship between horizontal displacement, x component d, how it goes this far, but at the same time it falls certain vertical distance. So, for example, if you increase this distance d 2 times, how much delta y would change? So you need a relationship between them. So again, we are looking for distance and x component of motion and y component. So I can use this formula, second formula, to determine, I can write this for y component of motion. Okay, second equation for y component, I can write y equals y0 plus v0 t minus 1/2 g t squared. I'm writing this for vertical component. Vertical direction, I have acceleration is negative g. Okay, here I'm dealing with velocity, and I need to find the relationship between delta y and horizontal displacement d. Okay, how can I do it? First of all, this thing is thrown horizontally. Initial y component of velocity is 0. Initially, because the very initial point, it is horizontal. There's only x component. The velocity v0, y is 0. This goes away, and then I can write, okay, this is y0, this is final y, okay. Basically, this delta y is y0 minus y. y0 minus y equals 1 half gt squared. So now I don't have the time. However, I know the total horizontal displacement, and I know initial velocity is horizontal. If initial velocity is horizontal, that's x component of velocity. If you throw something horizontally, that initial velocity is x component, and it is constant because x component does not change. Total x is horizontal displacement is v0x times time, right? This is total displacement. And this v0 is simply v0 because it's horizontal. From here, time equals v over v0, right? I can replace this t, time, with this expression, and I get that relationship. Now I get delta y equals 1 half g times square of time, and the time is distance, horizontal displacement divided by horizontal velocity. Horizontal displacement squared is v squared, right? Both should be squared, v0 squared. So now I know that this is a quadratic relationship. If you increase distance 2 times, delta y would increase 4 times. If you decrease the distance 2 times, the vertical fold with decrease 4 times. This increases 10 times, delta y changes the squared and x squared times. This is the relationship between these two things, and we can use that relationship to find other things. So this problem says in problem 2, if delta y, if vertical fold is 9 meters, find time in the air. Any questions on this? So this is easy because as long as you have found number 2, you can do number 3. Number 3 says, this is number 3. If a vertical fold is 9, it falls 9 meters vertically during this whole travel. Okay, find the time of travel, find the time in the air. You have a formula already for that. So vertical fold, delta y is 1 half gt squared, right? You know delta y, you know g, find t. So you solve this for time. If you multiply both sides by 2 and divide by g, you get t squared equals 2 times delta y divided by g, right? And t would be square root of this, right? A little more than 1 second total time of travel of this object. Okay, now the next problem. The next problem is related to this equation, the same equation. Now, if initial velocity is given, 60 meters per second, find velocity before hitting the ground. No, before at the end of this travel. find velocity when it hits the cliff in front, okay? You should find final velocity at this point if initial velocity is given. So now you know a lot of things. You know the time of travel, your initial velocity, so you can solve this. Again, final velocity, total velocity has x and y components. We need to determine x and y components of velocity. So Vx final is V0x plus 8xt. So first of all, there is no acceleration in x direction. This goes away. And second, the object is thrown horizontally. Horizontal initial velocity is simply x component of velocity. This equals V0, and we know it. It's given like 16 meters per second. Now, how about y component of velocity? Y component of velocity is V0y plus ayt. Okay? Initial velocity plus acceleration times time. This is simply this first equation. Final velocity equals initial plus acceleration times time, written for x and y component. For x we are done. For y, there's another simplification. Initial y velocity is 0, so here this becomes 0 for y component, and ay is negative g, this is negative gt. Time we just determined in the previous example, previous problem, 5 was 1.35. Okay, multiply negative 9.8 times 1.35, you get negative 13.3 meter per second. Now you know x and y components of velocity at the end of this travel when it hits that cliff in front of you. So total velocity final equals Vx squared plus Vy squared square root. You know both of these numbers. You find the final velocity just before it hits the cliff, just before, at the very end. So this is another problem. So there's a train. Trains enters the crossing. Suppose this is the crossing from here to here. The train enters the crossing, goes through the crossing, and clears the crossing. It has acceleration, it has initial velocity. So this is what is given. So this is the crossing. The train moves this way to the right. Initial velocity, 46 kilometers per hour. It has acceleration, 2.2 meters per second squared. You know the width of this crossing, okay? 25.6 meters. And total time to clear the crossing. Total time is at the instance when the train shows up here. Initial time and final time when it clears. This is not the final time. The train should clear the crossing. When it disappears, that's the end of the time. When it appears, that's the beginning of the time. Total time is this many seconds. Okay, you need to find the length of the train. Find the length of the train. So this is related to distance travel, time, acceleration is 0. So I'm looking here at this distance travel, is 0, time, acceleration. So I can use this formula. Basically, total x minus x0 will be total distance travel, right? Now, what is total distance travel? The train, for example, for this point, at the front of the train. This point travels the whole width of the crossing, but it also needs to travel the length of the train itself. If the length of the train is m, total distance traveled is L plus B during this time. When it appears, and then it clears the crossing, this is total distance traveled. And for total distance traveled, here total distance traveled is h minus h0, because initial velocity times time plus 1/2 at squared. I'm simply writing that same thing, v0 t plus 1/2 at squared. I'm asked to find the length of the train, L. B is given, so it's easy, like I move D to the other side, like L equals this thing minus D. So all these things are given. However, we should pay attention to the units. So acceleration is okay, it's meter per second squared. Time is seconds, it's okay. Velocity, 46 kilometers per hour. So you cannot use different units in the same equation. All units should be consistent. So we need to convert initial velocity, v0 is 46 kilometers in 1 hour. So I need to convert it to meter per second. Okay, in order to get to the kilometer, I got 1 kilometer is 1,000 meters. Now kilometer goes away, and 1 hour is 3,600 seconds. Hour goes away. 46 times 1,000, 1,000 divided by 3,600 equals
12.7.
12.8 meter per second. Okay. So I use this v0, time is given, a is given, I determine the length of the train is 56.5 meters. So the next is about this same problem. Problem 5, find the velocity at the time point at the end of this clearing the crossing. What is the velocity at the time when the train just disappears, clears the crossing? So velocity, I can consider final velocity. I know initial velocity, I know distance traveled, so it's just this one-step problem. So I'm asked for final velocity when initial velocity is given, acceleration is given, and total distance traveled is to determine is the length of the width of the crossing plus the length of the train. I'm hoping this formula for this is one-dimensional motion. V squared is equal plus 2 times a times total distance. I can consider this x-axis. This is total distance traveled. Okay, D is given in the previous example in the problem. Final velocity, I just take the square root of this v0 squared plus 2 times a times b plus k. Okay? So D was given initially, and L we determined. So I plug in the numbers here. Everything is given. Acceleration at V0 is given initially, D is given initially, the length we determined in previous problem. So the next problem is
Previous one. This guy makes 2 less than 1 time, and that's wrong.
the two runners, one is behind the other by a certain distance. Is the situation runner A and B, and they run along the same axis, the same line, the same straight line, the same direction. They have different velocities. This is velocity A, which is behind 12 meters. Runner A is behind by 12 meters. Runner B is over there. The runner B is running faster. Okay, it's behind but running faster. So A is 7.2 meters per second, B 5.4 meters per second. This is the distance between them initially. So they are running with constant velocity. The one in behind is running faster. They reach the finish line at the same time. You need to find the distance of runner B from the finish line at the initial time point. So what was the distance of runner B from the finish line initially? Okay, they start at this point, we consider the 0 time, they run and they reach the finish at the same time. What is this distance from runner B at the finish line? BB, distance for B. So we need to pay attention what is given, what is the situation. Something that we know, it says they reach the finish line at the same time. So if this is your time, before reaching the finish line, the time spent by each of them is the same. Time of A equals time of B. And this gives you a clue to solve this problem. So this is what we know, that they run from this point to the finish, they spend the same time. Time of A equals time of B. Okay? And then we know that for each generic formula, distance equals velocity times time, and from here time is distance divided by velocity. Now we can write for each of them distance of A from the finish divided by B of A equals distance of B divided by B. So, and there's one more thing. So what we know, distance of A from the finish is distance of B plus 12 meters. So A is farther away. A is behind the B, so distance of B from finish line is 12 meters more. So you can write B A is BB plus 12 meters. Right? So you can put this dB plus 12 meters in this equation. You can replace dA with dB, and then you get the one equation with one unknown, which is the thing that you are trying to find. You are trying to find dB, distance of B to the from the finish line. Right? They run at the same time. It says they reach the finish the same time. Their time. Their values are 2 times are the same. They run for the same time. Time is distance over velocity for both of them. And you know that the distance run by runner A is 12 meters more than B. And then I replace dA with this. I copy this equation, replacing dA with dB plus 12 meters divided by dI equals dB divided by dB. So this is one equation with one unknown, so we can do cross multiplication. This times this equals this times this. Okay, or dB plus 12 dB. I multiply this with this equals dB dA. My unknown, I'm trying to solve this for dB. This is the d from the finished one. I have one term, the second term that contains the unknown. Therefore, I can combine the terms that contain the unknown on one side and the knowns at the other side of the equation. So I can think dB to the left-hand side. This goes to the left-hand side. And here I have dB minus dB dA. And this can go to the other side. It becomes negative dB. When you move something from one side of the equation to the other, it changes sign. This was positive, became negative, this was positive, became negative. And then I solve it for dB minus dA equals negative 12 dB equals negative 12 dB divided by dB equals dA. So, or I can change the sign of both numerator and denominator. So you can solve it like this, or you can multiply both upper and lower parts by negative 1. This is the same as negative plus dB.
What the fuck? What is this? It's not the battery, it's the storage. I think I played too much Pokemon Go. I should have really liked the app before I went to here.
So this is vector addition.
I want to kind of like delete some stuff right now, but I can't. What?
Two vectors. So the simple equation, there are two vectors A and B. You know the magnitude of the vectors and their angle relative to positive x-axis. Alpha is the angle for A, beta is the angle for B. Is B, this is A, find the vector sum of these two vectors. So you can add this convenient to do it using x and y components. Vectors, so AX is A cosine alpha. If these are forces, they are given in newtons. Okay, but it doesn't just the unit, it doesn't matter. So, and y component of A is A sine theta, sine alpha for A is equals 199. The same for B, okay? X component of B is B cosine beta X component. For B, both X and Y are negative. It's in the third quarter. Both X and Y are negative here. It's negative 307. And BY is B sine beta is again negative 109.4. Now you have x and y components for both vectors. If C is the vector sum, then Cx would be Ax plus Bx, and Cy would be Ay plus By. Okay, just don't forget to use this negative signs for components of B. And for components of C, you get X component is negative, and Y component is positive. So when you get these components of the resulting vector, it's useful to sketch that vector. So you should know where this vector is. That's useful for providing the correct answer for the angle of that vector. So if the X component is negative and Y component is positive, right? For this vector, X is negative, Y is positive. This vector would be somewhere. Also, you can use this parallelogram from tip of one vector, make a parallel to the other vector, and from the tip of the other vector, parallel to this vector. So this would be your vector, C. X component is negative, Y component is positive. This is approximately, at least approximately, you should know where this vector goes, what direction. And then second part, in order to find the vector, you need not only, first of all, we need to determine C magnitude equals CX squared plus CY squared, and that's the magnitude of the vector. You also need the direction. The vector is not determined before you determine both magnitude and direction. The angle, when I can call it gamma, because gamma comes from our vector. So now it's an inverse tangent of the Cy over Cx. Okay, the one is positive, one is negative. This is going to be a negative number. For this angle, I get negative 28.3 degrees. If you are required to provide this angle relative to positive x-axis, you need to make sense of this angle. So this negative 28, and this is your vector. So this negative 28 is this angle. So the real angle gamma would be 180 degrees minus 28.3. So if this is your vector, you determine, because it has positive y component negative x, and by sketching you get this, and you get negative angle. That angle shows the tail, the orientation of the tail. The real angle gamma for any letter you can use for that is 180 minus this angle. Okay? So make sure that, but pay attention how the problem is formulated. Does it require the angle relative to positive x, or just determine the angle? Usually it tells you how to provide the angle. Okay, this would be the proper way. 151.7. Okay, make sure that you are able to do this. So we have done this several times, and you can chart this.
That's the last problem. I think so.
The storage is full.
What?
I thought your storage was full.
What?
The storage. I thought it was full.
Dude, I didn't know this thing goes into my storage. I thought it just literally just uploads on Facebook and that's it. It's so soft. I'm so scared because I have like 100 megabytes left, I think.
Programs are multiple choice. So multiple choice, A, B, C, D, E. So in other words, you should be able to figure out which answer is correct. If you have no negative number in the angles and you get negative 28, you should try to convert that negative to positive, as I described. If you still are having difficulty, you can come to my office Friday, my group, or as I said, email. or we can make an appointment. I will be working with you as much as I can. If you need help, don't hesitate to ask for help. So this is another problem. There are some logical questions that in order to answer, sometimes you need to use the formula. For example, two situations, two experiments. So one object is thrown at a certain angle. This is a projectile. It reaches the highest point and then comes down, hits the ground. So the second experiment, you keep another object or the same object at this same height. So this edge is this edge at the same height, and then let it go from rest. Now consider two things. The time for this first object that takes for it to go from the highest point to the ground. It reaches highest point, 0 time. How much time takes for this object to hit the ground? From the highest point when it is thrown at a certain angle. The other is held at rest at that point and just you release it. And time 2. So the same time, this is time 1, this is time 2. So does it take longer, same time or shorter time for this object to hit the ground? So basically you are considering motion, vertical motion, time. So let's try to use this second equation for y component of motion. I can write this second equation for y equals y0 plus v0 y component of velocity minus 1/2 gt squared. So I consider only the part of half of the motion from highest point down to the ground. So basically I can write this y0 minus y. This is the height, which for both of them, y component of velocity is 0. One has reached highest point, and at highest point, y component of velocity is 0. For both of them, this v0, y is 0. At this point, highest point, vertical component of velocity is 0. This is released from rest. So both of them, this becomes 0. And I get this y0 minus y is basically vertical distance traveled, which I consider height. So this is equals height, and height is 1/2 gt squared. As you can see, the height is simply 1/2 t squared. G is the same for both of them, right? Anything thrown into the air has only one acceleration. That's g. And this goes downward. Doesn't matter if it had initial velocity, you release it from the rest, you throw it upward, you throw it downward, you throw it horizontal. Object in the air has only one acceleration, that g acceleration, it is directed downward. So as long as height is the same, time is the same. Okay? Because t is 2 times square root of 2h over g. As long as h is the same, then t1 equals t2, because they start from the same height. So there may be other questions like you are throwing something this way and this way, and the questions are A, B, C, D, E. They both have the same velocity, they both have the same acceleration. One thing you know is all projectiles that are thrown into the air, they have the same acceleration. Velocities can be different initially at a certain time. Velocities can be different. No acceleration along x-axis, no acceleration, velocity is constant along x-axis. One acceleration, g acceleration along y-axis. Same acceleration for all projectiles. That's all? being scoundrel, pencil.
Alright, how do I stop this shit, girl? How do I stop this? What the fuck? How do I stop this?
Wait.
How do I end this? What the hell? Oh my god, I'm about to stop this. How do I? Wait. Oh, is this it?
That's filter.
What the hell? How do I stop this? Someone save me, I'm gonna lose all my memory.
Try to exit out.
Oh wait, I see it.